AutoCAD uses the very popular Cartesian coordinate system for making the drawings, and in Cartesian coordinate system we have x, y and z axis. Here we have this x-axis represented with a red line, the y-axis represented with a green line, and we also have a z-axis which we cannot see because we're in the 2D plane. The z-axis is pointing outwards from the screen right now. Now all the points in this Cartesian system are measured from this point, which is the intersection of x and y axis, or the intersection of x, y and z axis in 3D, and that point is taken as 0, 0, 0, and each 0 represents the x, y and z axis respectively. Now if you talk about 2D coordinate system, we only have x and y axis. So the first coordinate point will be the x axis and the second coordinate point will be y axis as shown here. Now if you could see the grids in this drawing area, you'll notice that I have divided this complete block into 10 grids in horizontal direction. So we have these 10 grids in the horizontal and 10 in vertical direction, and the size of each block of this grid is 1 by 1 unit. So the length and width of this block is 1 unit in each direction, and the size of this big block is 10 units in length and 10 units in width or height. Now in order to find the coordinate of any point with respect to the origin, all we have to do is find out its x and y values. So let's say that we want to find out the coordinates of this point. So all we need to do is count the number of x blocks and then the number of y blocks. So in this case we have number of x blocks as 10. So after 10 blocks we can make a line that will intersect this point. Now after 10 blocks along y direction, if we make a line, it will also intersect the same point. So the coordinate of this point is x10, y10, and that will be 10, 10. Now similarly in this case we have this point, and the coordinates of this point will be 10 in x-axis because after 10 blocks along x-axis we have this point here, and the y-coordinate of this point will be 4 because after 4 blocks we have this point. So the coordinate value of this point will be 10, 4. Now that's the simple Cartesian coordinate system. Now if you want to use the polar coordinate system, then you can do that as well, and I have made a geometry here. Now this line starts from the origin and the length of this line is 10 units. This line is also inclined to an angle of 30 degrees. So if you don't want to specify the end point of this line in terms of Cartesian coordinate system and you want to specify it in other units, which is the polar coordinate system, then you need to represent the values as the length of line and the angle included here. So that will be the length, which is 10 units, and then the angle, which is 30. So this will be the value in polar coordinate system. So now we can represent this endpoint in terms of polar coordinates using this coordinate value, and we'll learn about this later on in this complete course. So now here we have a completely blank drawing area. So in the current drawing area we don't know the extent of dimensions. For example, if we make a line of length 10 units in this drawing area, we don't know how long it will be. So in order to set that limit, we can use the limits command. So type limits and press enter. So now this will prompt you to specify the lower left corner, which is 0, 0 in this case. So simply type 0, 0, or you can directly press enter because the values in this angle bracket is the default value that will be accepted if you directly press enter. So you can also directly press enter. So I'll now press enter, and now you'll notice the upper right corner value, and the upper right corner value is simply the values of coordinate on this corner. So you can see that the lower left corner values are 0, 0, and the upper right corner values are 420, 297. That means the length of this screen should be 420 units and the height should be 297 units, whatever the unit of current drawing is. But that's not always the case. In this case, the height is obviously 297, but depending upon the aspect ratio or the screen resolution or the size of a screen, your length may differ. So obviously we know that the length of upper right corner is 297. So if you want to accept the value, simply press enter, and if you want to change these values, you can do so by entering the new value. So I'll type 100,60 and now press enter. So now we know that the height should be equal to 60 unit, and depending upon that height, the length will adjust automatically. But before checking that, we need to ensure that the settings are applied, and the settings can be applied by using zoom all command. So type Z for zoom, press enter, and then type A and press enter. Now the settings are applied. So let's make a simple line. I'll go to this line command, and we'll learn about this line command later on in the next module. And now click at a point somewhere close to this bottom point, and now make a straight line of length 60 units and press enter. And you'll notice that the length of this line is equal to 60 units, which we have already set in the limits. So now we know the limit of this current screen, which is 60 by almost 100 or 120. Now we also need to know the unit of the current drawing, and for that you can check the display unit by clicking this application button, selecting the drawing utilities, and from here select the units. So now you can see the display unit or the units which will be displayed in the drawing area from this window. So right now the length has decimal type here, which you can change to architectural. If you want to see it in feet and inches, you can see the sample output here, and I'll change it to decimal again. Now here we have the precision. So currently the precision is set to 4 decimal places. You can change it to 2, 3 or whatever value you want. So this will not change the actual precision, but it will only change the precision of the values which are displayed on the screen. So I'm changing the precision to 2 places, and now the insertion scale, which will be the scale of external geometries which are inserted. It's set to mm. You can change it to any of these units, whichever you want. So you can change it to inches, you can change it to feet or something else. So I'll keep it at mm. And here we have the angle type, which is set to decimal degrees. You can also change it to degree, minute, second, grades, radians or surveyor units. And here also we have the precision, which I'll change to 2 decimal places. If you want to reverse the direction of positive angle, you can click on this clockwise checkbox. So the anti-clockwise direction is generally taken as positive in Autocad, but if you want to reverse that, you can click on this checkbox to make clockwise direction as positive. So I'll keep it unchecked, and now I'll click on OK. So we have set the display unit for this drawing as well. We have also set the limits. In the next lesson, we will learn about saving these settings as a template file. So now we have defined the units as well as the limits in our drawing. We will save these settings as a template. But before saving the settings as a template, we'll change some of the parameters on the status bar of our drawing, because these parameters are really very useful, and we'll learn about these tools and these status bar toggles in the upcoming modules. For now, we'll simply keep a simple kind of setting that can be used in the upcoming lessons. So make sure that this grid display is off, although you can keep it on. If you keep it on, it will show this grid, but if it is visible, just keep it off. Also, this snap mode should be off, so that's a very important option. This should be off, and when it is off, it will show like this gray icon. So all of these icons will show like these gray icons. So if it is off, it will show like this gray. Now this grid snap both should be off. Also make sure that this dynamic input is off. So in your case, you may not be able to see this kind of tool, the dynamic input tool, and if it is not visible on your status bar, then go to the customization on the far right and select dynamic input. So keep this option checked. So right now we have a lot of different options here, and only the options which are checked will show up on the status bar. So make sure dynamic input is checked, and once it is checked, it will show up here on the status bar, but now unchecked from the status bar. If it is checked, it will show like this blue icon. Just make sure it is unchecked. Also we have the ortho as well as the polar tracking. So make sure this polar tracking is on, not this ortho. So right now all of these options should be off except this polar tracking, only this should be on. Also make sure that this object snap should be on and object snap tracking should be on. So we are keeping only 3 options: polar, object snap tracking, object snap. So these 3 options should be on. Rest of the options can be kept off. So you can just deactivate all the remaining options, but make sure only these 3 options are on, because these are the settings that we will use for the remaining drawings. Now, since we have already set our limits and units, we'll save that as well as this status bar setting as a template. Now to save it as a template, go to this application button and select save as. Now drawing template. Now this will open the default template folder, which is located deep within the installation directory. You can see that it is deep within that C drive and the installation directory, but you can save it at your desired location. So in this case I'll save it on the desktop. So I'll go to desktop and I'll give it a name, sample template in this case, and look at this, we are saving this as a DWT file, not as a DWG file. So the template has this DWT extension. Now click on save and it will prompt you for the description. If you want to add that, go ahead, do that, else click on OK. Now that template is saved on the desktop. If you want to open a new drawing with the template which you just created, you can go to this new icon and it will open this template folder. Then click on desktop, locate the template, click on open, and once again it will open your drawing with all those default settings on the status bar as well as in the background, like units and limits. So now we have completed the first module. Let's look at our first question, which is related to the topics which we have covered in this module. So we need to make a template in Autocad with name my template, and that template should have architectural unit display format. Also that format should be at a precision of 1/4 of an inch. Also ensure that inches is selected as the unit, and the limit of this template should be set at 50 units in vertical direction. So these are different points that you need to keep in mind. Now let's get back to Autocad. So when you launch Autocad, you reach this 0 screen, and here in this 0 screen you need to launch it with the default template. So I'll click on start drawing, and here we have it, the default template. Now let's check the unit. So I'll type dash DWG units and press enter. Now here you can see that on command line we have 1 within angle brackets, and also 1 is for inches. So we have this unit perfectly set, but in case the unit is different here, if it is set to 2, 3, 4 or any other value, then change it to 1 and press enter, and keep rest of the settings at their default. Now I'll simply press escape here, and now type UN for units and press enter. So here we need to make some changes. The first change will be the type of display format, which is set to decimal. We need to change it to architectural, and also the precision should be 1/4 of an inch, which is here. The insertion scale should also be set to inches, and we'll leave rest of the options. I'll click on OK. Now we need to make the third setting, and in case of third setting we were required to set the limits in vertical direction to 50 units. So I'll type limits and press enter. Now I'll select lower left corner as 0,0 as specified, so I'll simply press enter, and the upper right corner should be whatever value. I'll type 100. In the horizontal direction that hardly matters, but in vertical direction I'll keep it at 50, and in both the cases I'll add this inch symbol, so 100 inches by 50 inches, and press enter. So we still have the old unit. The new units are not yet applied. To apply them, simply type Z for zoom and A for all. Now the limits are applied. So we have made all of these changes. Now we need to save it as a template. So I'll go to this application button, select save as, drawing template. Now specify the location. I'll go to desktop, give it a name. So let's name it as my template, and you can see here DWT extension. Click on save, and with the default description, okay. Let's minimize it, and here we have it. We have this my template on the desktop.